you had a plan for its future, and that you knew what would happen over the thousands of years since your creation into the world, and that your Son Jesus would come and that would provide a means of salvation for the world. In our society, this topic of whether you created the world or whether it evolved has caused the faith of many people in you to wane. People have an excuse for not believing because they think we all evolved without really understanding or thinking about it. So we ask that you will be with us and give us open ears as we listen to this address this evening, that we will understand and have our faith encouraged in the fact that you did indeed make the world, and that evolution isn't an obvious fact like it is so often presented to us. We ask that you will be with us and be with Jeremy as he presents, and we pray through Jesus. Amen. So again, we won't be having a reading to introduce the talk. Brother Jeremy will be referring to various Bible passages as we go through. So I'll now hand over to Jeremy.
Thank you, Matthew. In actual fact, I will not be referring to many Bible verses tonight because I'm going to be operating basically from information which is coming from the world around us to refute evolution. Well, first of all, let's just discuss certain things about this topic of refuting evolution. Why refute? Well, I want every one of you in this room, when you leave this room tonight, to have some ammunition available. So when you are talking to somebody about evolution, you can start to cite various things which you can tell them, which will start to get them to think about whether or not evolution is right or wrong. I want you to be able to talk to somebody who believes in evolution and start to throw doubt in their mind as to whether or not evolution is right. And if you throw that doubt in their mind, if you throw that doubt about their faith in evolution, and that's what it is, it's a faith in evolution, then I think you will have achieved something. And there are a lot of people out there who just now take evolution as understood and believed by everybody. And they are a little bit surprised sometimes. And sometimes when you start to say, well, I don't believe in evolution, they might start to get a bit on their hobby horse and say, oh, of course you believe in evolution. Science tells you that. Well, I'd like to question that tonight. I don't think that science does tell you that at all. So again, you've got to be wary of that, if you like, the scoffing approach. Oh, you wouldn't believe in this if you were scientific, or you wouldn't believe in this if you really were up to date with science. And the other thing is, you've got to be wary as well, because when you go into this business about refuting evolution enough, you could become the same way. You can start to think, how stupid is a person who believes in evolution? How could you possibly believe that? So you've got to guard yourself from the same sort of reaction of not being in any way scoffing of people who might believe in evolution, even though they will proclaim that they do. So therefore, tonight we're not going to be complicated. We're not going to get into the complexities, if you like, of the so-called science around evolution. I want you to just take a few simple ideas away tonight so that you can talk to somebody and you can start to get them questioning whether or not they're on the right track when they believe in evolution. We could have read Genesis chapter 1 tonight, and I was of two minds to do it, but I thought to myself, well, if we do that as well, we're going to be running tonight rather long. But what I do want to establish tonight is that the record of Genesis chapter 1 is straightforward. And it is verified not only in the Old Testament, but by people who say that they believe it in the New Testament. And one of those people who says that they believe in the creation record in the New Testament is Jesus Christ himself. He believed in Genesis chapter 1. And there are several examples we could have gone to, but the one I'd like to reference here is Mark chapter 10 and verse 6, where he simply says, this is Jesus talking, but at the beginning of creation, God made them male and female. So if you start to question the Genesis record, you're also questioning the words of the Lord Jesus Christ himself. So let's go to this idea of science. Now, all of us at some stage have been in a classroom and you've been taught science. You also are aware of the fact that in this society in which we live, science is held in very high regard. If you are a scientist, people start to think you're an expert, and therefore they start to pay attention to what you say because you are a scientist. They're thought of objective people, people who aren't swayed by, if you like, arguments which are emotive or emotional. They're supposed to be clear thinkers. And therefore, because they're scientists, they're clear thinkers, and therefore you should pay more attention to them. That's a sort of logic which we get in our society. But let's go back to what science really is. Okay, you can go to a lot of places for definitions. Here is one. Science is the intellectual and practical activity encompassing the systematic study of the structure and behaviour of the physical and natural world through observation and experiment. And as I said, all of you at some stage in your careers have been in a classroom, you've learnt some science, and that's what the definition of that science which you have learnt is. And therefore, of course, scientists will tell you in fairly graphic way that they are using the scientific method. What is the scientific method? Well, here is an illustration of it. You ask a question about something in nature. How does this work? You do some research to find out how it works. That might be in the laboratory. You come up with a hypothesis, which is just a calculated guess. You then undertake some experiments to see if that guess is accurate. You look at the data which you've collected from those experiments and you decide whether it's right or wrong. If it was wrong, you go back and come up with another calculated guess or a hypothesis and start it all over again. That is what we call the scientific method. Now, the scientists have no jurisdiction on it. They don't have a personal, if you like, license on this scientific method. I would suggest to you all scientific method is clear thinking. It is logical, and it has been used for centuries by different cultures and different races because it is simply that. It is just a logical way of approaching research of anything, and it has been done for a long period of time. So therefore, although they claim it to be something new, it is nothing new at all. Now let's have a look at the types of science which exist in this world in which we live. There is operational science, as it's called. We can categorise this as normal science. This is what you did in the classroom. This is what you may have done at university. It deals with repeatable and observable processes. In other words, you can, whatever you've seen happen in nature or happen in the environment, you can take into some laboratory, scale things down, and you can duplicate it. In some way, you can duplicate it in a laboratory. You therefore learn about the way the environment works. You learn about the way chemicals react. You learn about the way as the system operates, and you can repeat the process time and time again. Therefore, you have proved it as science to be something which is repeatable and therefore operational. And of course, we know that science in this type has led to many improvements of life. It's led to many scientific breakthroughs. We've led to many medical breakthroughs. We've got no doubt in our mind that science has helped mankind no end over the centuries. That is that type of science. It is not all types of science. It is that type of science. Because there is a second type of science, which I want to deal with this evening, called origin science. Now, this in a way is a little bit more like archaeology than science as we've just described it in that first category. They still work on hypotheses, this time about the past, and it's on the basis of causality. In other words, everything they assume has had a cause at some stage. And therefore, because of that, we might be able to go back in the past, work out the cause is, and therefore deduce from that that this is the way something came into existence. It also assumes that the processes which have been occurring in the past occur in the present. It's also assuming that the rates at which things happened in the past are occurring in the present. For example, when I was a teacher at school, a long time ago, I used to tell the boys about something called continental drift. And I said, okay, the average speed of continental drift is about the same speed at which your thumbnail or your fingernails grow, which is twice the speed, I'm told, at which your toenails grow. So therefore, if you can look at your toenails, your fingernails growing, that is the speed, the average speed of continental drift around the world. And therefore, because of that, you extrapolate into centuries, okay, for this country to go from, or this continent to go from here to there, it must have taken so many million years, because on that rate, it took that long to do that. That's a big assumption, isn't it? How do you know that? Well, no one does, because no one was there. And therefore, if for a while, rates of continental drift were 3 or 4 or 7 times as much as they are today, you can't say whether it would or would not have happened that way. And so therefore there is a lot of, and I'll use that expression, guesswork, a lot of guesswork in relation to origin science, because you can't repeat the process in the laboratory. You can't come these things and say, okay, this took 40 million years to do what this did. Let's now take it to the laboratory and see what 30 or 40 million years do to it. It's absolutely ridiculous to do that, isn't it? Or even to think of doing that. And so we have this great line of demarcation, I would suggest to you, between operational science, which is what we tend to think always science as, and origin science, where there is a lot of deduction, a lot of speculation, a lot of premises assumed before conclusions are drawn. And are those conclusions conclusive? Well, I would suggest they cannot be. So is this science? Well, that's a question, isn't it? By strict definition under operational science, it isn't. But when you read about it in the newspaper or in various journals, it calls itself science. It really could, I suppose, be better described as origins science. Now, I don't know why this has gone so small, but it has. Very small. But what I wanted to do in this particular slide is to look at what this particular idea is of evolution. Now, I'll have to read it out because you cannot see it, and I don't know why. As I said, it's come that small. This is just a different computer I'm using now at the moment. But reading it to you, it says, evolution is a theory that explains how life on Earth has diversified into millions of different species. Now, even what I've read out there makes an assumption, an underlying assumption. Evolution is a theory that explains. And I have, although you can't see it, put in brackets what really it should say, that seeks to explain. In other words, tries to explain. Because if you go to Wikipedia or go to a lot of places, it makes it sound as though it's fact. It makes it sound as though it's indisputable. It makes it sound as though everybody believes it. And that is a con. That is not right. And so therefore what they're doing is they're trying to say something which is a theory is an actual fact of fact. And that's why today, whenever we go along and we talk about evolution, people talk about evolution, they don't give it the full title. The full title is the theory of evolution. But if you talk about a theory of evolution, you're calling it a theory. If you talk about evolution, all of a sudden this omission of terms has meant that people are starting to regard it as a factual thing. And of course, what it tries to say is things make themselves. Think about it. If there's no God, things must make themselves. Somehow, things have been able to create themselves or make themselves. Sometimes we hear this expression, Mother Nature has done it, as if to say that's some sort of way in which it's accomplished, some brain behind it called Mother Nature has decided that this is what is going to actually happen. This theory all came from a book which was written in 1859 by a man called Charles Darwin. It was not called The Origin of the Species. Back in those days, they didn't give books simple titles. It was called On the Origin of the Species by Means of Natural Selection or the Preservation of Favoured Races in the Struggle for Life. That was the title of the book. And I understand Dawkins didn't even know that when he was interviewed on one occasion. But in actual fact, that was a proper title of the book which was written. And he wrote this book in 1859, and he came up with this theory. And this theory was also sometimes being called today uniformitarianism. In other words, Darwin believed that things were slowly evolving over time. He didn't know how long, but over a long time he conceded that, and changing into what they are today. This is the trouble with evolution in a sense when you argue against it, because nowadays Darwinism is largely not accepted. Uniformitarianism is not accepted. What most evolutionists will talk about now is what they call catastrophism. That is, evolution goes slowly along for a period of time, and then all of a sudden, whoop, jump. All of a sudden, there's a massive amount of evolutionary change. And then it goes on in this dynamic equilibrium situation, and then there's another jump. Now, the reason why they had to come up with catastrophism is because they appreciate the fact that uniformitarianism doesn't work. That is outside the, if you like, the limits of what we want to say tonight. But just let me make this point. If you argue against evolution or the theory of evolution, I think the very first question you need to ask is, well, what theory of evolution do you actually believe in? Are you back with Darwinism, uniformitarianism, or do you believe in catastrophism? Or do you believe in some of the variations on catastrophism, which are also around today? So it becomes a little bit clumsy and awkward if you're really talking to somebody who knows a bit more than the obvious about evolution. The theory has been accepted by a number of scientists as fact. And because of that, they have based other theories on it. And of course, that means if you take evolution away, or the theory of evolution away, those other things, those other theories, those other ideas will also fall down too. And so there's a lot of science which has got a vested, or this origin science, which has got a vested interest in keeping this theory of evolution, whatever variation you want to have, as something which is in existence. Let's go now further and have a look at microevolution. Because again, there is not one type of evolution, there are two. And I have no problems with microevolution at all, because I think microevolution can be established very easily. I was teaching about it for years in my subject area. We didn't call it microevolution, we call it adaptation. That is, we appreciate the fact that living forms adapt to a degree to their environment. Species adapt to their environment, or as the Bible calls them, and species and kinds are not equivalent, but the Bible doesn't talk about species, it talks about kinds. Again, I would argue that if you go to scientists today, biologists, there is variations of what is meant by the word species too. And so therefore there are complications there as well. Okay, so this particular process of microevolution believes in or relies upon the process of natural selection. Natural selection is not a dirty term. We've got to accept, I believe, that it exists. And so therefore, if we look at that, what is the definition of microevolution? Again, it's not large enough for you to read unless you've got super eyes. But let me just read it to you and see if you can make sense of what it's saying. Microevolution is simply a change in gene frequency within a population. Evolution at this scale can be observed over short periods of time, for example, between one generation and the next. The frequency of gene for pesticide resistance in a population of crop pests increases. Such a change might come about because of natural selection favouring the gene. In other words, very, very simply, there are things which change within animals because of the environment in which they live. Darwin's finches, which is probably something which you have heard of, although I've just recently read that they weren't finches anyway. But anyway, Darwin's finches, when he looked at those, he collected 13 different types of finches, so-called, which were in this place called the Galapagos Islands. And he looked at the difference in the beak construction. And he decided that that beak construction varied from place to place because of the food that the finch was feeding on. As a result of that food, the beak would adjust, if you like, its size and its structure. The finch was still a finch, well, actually not a finch, but it was, anyway, the bird was still a bird, but the beak structure altered according to the food supply. The interesting thing was, if he'd gone back again, he would notice that some of those finches that he looked at, so-called, if that food supply changed, so did that same finch's beak structure in the next generation. So it was something which was altering according to the environment in which they found themselves. And there are many other examples of this. We can't deny it occurs in nature. It occurs, as I said, as a result. But whereas an evolution will say, oh, there's evolution, we will say, no, there's a designer. Let me give you an analogy of what I mean by that. In that car park right now, I have parked a Renault Clio. That Renault Clio is a little car. It's got 5 gears, front-wheel drive, and it's built by the designer to do certain things. It can adjust to the environment. How does it adjust to environment? If I'm going up a hill, I drop the gears. It now can make the hill. At night, I turn on the lights because the designer has designed it so it can operate at night as well. If I bought my other car, which was a Koleos, it's 4-wheel drive. All of a sudden, it's got all those other things it can do as well. Why? Because it has been designed to do those other things. It's been designed to accommodate a greater range of environments and terrains. It can go up a steeper hill because it's got 4-wheel drive. It can come down very slowly because it's got brake assist on the way down. You see what I'm saying? A designer would design things to change according to their environment. Just like designers of our automobiles design a vehicle to do what? To do what its environment is going to require it to do. Otherwise, it won't survive. It won't work. It won't operate in those environments. So for an evolution to say, oh, here we are, you see, this particular bird's beak structure is changing and therefore that must be evolution. It's going to become a lizard in 20 million years. No, it's got that inbuilt into it so it can survive because its designer gave it that design ability or gave it that function which could alter as a consequence. The fact it's more sophisticated than a gearbox or a 4-wheel drive system is neither here nor there, because we're dealing with, of course, as we know, a designer who has got an incredible amount of ability. So coming back to this idea of microevolution, we call it natural selection, and just very simply, I'm running out of time already. I apologise for going so slowly. Perhaps I am going too slowly, but we've all seen this. The idea of natural selection, and you might have seen in biology textbooks something like you've got on the screen there, which is the right size. And there you've got there what we call genetics. We've got 2 dogs, for want of a better expression. The dogs have medium length fur, and they have a litter of 4 dogs. One has short fur, one has medium fur, one has long fur. Now let's just suppose in that environment that it gets very cold. Who's going to survive of that litter? Which one's going to survive? The short hair one? No, that'll die because it can't deal with a cold environment. Even the medium hair length will die because of the environment it finds. The only ones which will survive will be the long hair. So when the long hair animals breed, anything which is other than long hair, because of that environment, will die. And that is what we call microevolution. That is what we call adaptation. That is why it has been designed to occur. And so that species will not go out of into extinction because the environment closes, because it has been designed to deal with that, because in its genes is the information it needs to do that. Now, that's not new information. It was always there. It just come through in the generations because that was required for that animal to survive. And the animals that didn't have those genes did not survive. And so the only ones that successfully bred, of course, were those long-haired animals. And that is, as said, commonly seen in biology as an explanation of long-term evolution. It is microevolution. It is adaptation. It is the result of a designer designing into an animal the ability to survive even though the environment may alter. This is what we have problems with. This is what is wrong. It's called macroevolution. And we do have problems with it because it is used to explain the origins of all life. The term macroevolution, and again, I've got a definition here from Wikipedia, can be used to explain the shared common ancestry between all living organisms, a concept known as universal common descent. This describes a derivation of all existent and extinct life forms from a single origin and includes evolutionary milestones such as origins of plants, mammals, reptiles, birds, fish, etc., etc. It's supposed to have taken 3.8 billion years. It's called deep time. And again, you might have read that expression in some biology textbooks over the year. It is a quantum leap, I would suggest to you, from a belief that an animal can adapt to the environmental change which it finds itself in, and to say that a lizard is going to turn into a dinosaur, which is going to turn into a fish. Those sort of changes are, again, a lot bigger. This has been called sometimes goo to you evolution. A little catchy phrase which you might like to remember, because this is what macroevolution is, goo to you evolution. It did not take place. Let's look at a couple of reasons why we say it cannot take place. You probably have come across that again, what we call the typical life tree. We've got a common ancestor right at the bottom, and that common ancestor is supposed to branch into all these different life forms, as you can see, from bacteria all the way through to snakes on the right-hand side. They've all come from something, and that is what they call the common ancestor. Why doesn't it work? Unfortunately, again, we've gone down into small size for some reason. But if we just go through this, what we have here is where this particular original ancestor is supposed to have come from. It was what they call a primordial soup theory. And in 1929, a scientist called Haldane came up with this theory. And his idea was that there was this soup, this chemical mix, which occurred somewhere. Now, the question is, where did it come from? And of course, one of the common criticisms of people who believe in God, where does God come from? And if you say, well, God has always been there, they say, that's ridiculous. God's never always been there. Nothing's ever always been there. And yet, the theory of evolution is based on the fact that something was always there. Where was this primordial soup originally? Well, it was always there, presumably, and all these chemicals floating around this primordial soup, and this atmosphere around it was always there. And then it was struck by lightning, and all of a sudden, bang, we have light. Now, life, when you think about it, that is the simplistic basis on which the theory of evolution is based. That a chemical soup in an atmosphere of various gases is struck by lightning and life is formed. That is where it's got to start. And yet when you think about it, that is just, if people are criticising you because you believe in a God which is going on forever, and then they've got to have the same sort of logic in their own theory. It doesn't work. It doesn't cut it if you're going to criticise something for it and then do exactly the same thing. Now, can we regard this as science? No, we can't, because this happened, 3.8 billion years ago? No one saw it. And if you take the situation in the laboratory and say, okay, well, primordial soup, let's make one and let's create life. Let's make this soup of whatever you think the chemicals are. Let's strike it with a few million bolts of lightning and see what happens to it. Can you duplicate life in the laboratory? No one ever has. And I'd suggest to you no one ever will, because it's not going to ever happen, even though it's been tried. But even when you think about it, the fact that it's been tried, suggests that there's been what? A design behind it. Because the scientists went along and said, okay, let's have a chemical soup of this number of chemicals. Let's strike it this lightning on it. All that design has gone into it to even recreate an experiment where dumb chance is supposed to have done it all. This is not logical. This is not sense. And yet this is the logic which is used, as I said, to explain the theory of evolution. Where did the atmosphere come from? Where did the primordial soup come from? Is, as I said, the question which you can ask. And then, of course, they talk about, in that previous little tree, the common ancestor, the single cell, the simple cell, which started it all. There is no such thing as a simple cell. There is no such thing by a long, long way. All cells are highly complex. And that, when the theory came out of the primordial soup idea in 1929, that was not fully understood. But since then, we've understood that cells are very, very complex things. And so therefore, when we look at the simplest cell which is in existence, the very simplest, it's called Mycoplasma genitalium. Apparently it has 482 genes and 580,000 base pairs. Now, you don't need to know what they are. What this is saying to you very simply is that it's very complex. Even though it's a single cell, it's very complex. It's got all these, if you like, different genes. It has these base pairs in it. And not only that, it needs more than that, because that's just for it to exist. If it's going to reproduce, it's got to have a lot more complexity as well. And this particular genome is not even able to live on its own. It's a parasite. If you take away those things it lives on, it can't live either. So to have, if you like, a simple cell which is self-supporting, you've got to go even more complex than this one is in this example. So in other words, when you look at this, and it's been said time and time again by scientists, and even in the 1960s when they tried to come up with what they call chemical evolution, they tried to go into the laboratory and they tried to come up with some chemical mixes which would actually create life. Believe it or not, they tried. And in 1968, I think it was, the main scientific team which was leading that said, can't do it. We just don't think it's right. It just doesn't work. There must be some other way this happened, because it didn't happen in the chemical evolution format that we have described before. So they're again looking for any sort of plausible way in which life could have originated. Again, unfortunately, it hasn't come out as it originally did. But let me just go to this one. If you then start to question evolution on the basis of where did life come from then, this is another little one in your argument which you could use. It's called irreducible complexity. In other words, if you take away certain things, the organ won't work. Now, I've got here, believe it or not, a mousetrap, just to illustrate what I'm saying. Now, you look at that mousetrap. It's made up of a simple component or two, isn't it? But if you look at that and you take away the catch, will a mousetrap work? No, it won't. If you take away the platform, will it work? No, it won't. Will you take away the spring? Will it work? No. For a mousetrap to work, it's got to have the whole thing there. Otherwise, it won't work. Otherwise, it's just nothing but wire and a piece of wood. In other words, you can't take any of the complexity out of a mousetrap and expect it to work. Now, you just think of some of the things which we just take for granted. For example, you cut yourself and you bleed. Do you bleed to death? Well, if you're haemophiliac, you might. But if you're not, you're a normal person, what happens? Your blood clots wherever you cut yourself. Why does it do that? Why doesn't it clot in your arteries and kill you with a stroke? What meant, or what happened to actually mean that that particular system would be something which would form a scab on a wound that you have and yet not kill you if it was inside and clotting? How did evolution ever do that? That the complexities of that work just right to make sure you don't bleed to death and yet you don't suffer from strokes? We have Sister Debbie here tonight. She works with eyes. And I'm sure she, like all of us, understand that for an eye to work, you've got to have an awful lot of complexity going on, because there are a lot of people whose eyes don't work because something has gone wrong. Now, if you just think of an animal all of a sudden wants to have eyesight, wants to look at something. How does it evolve an eye? How does it do that? Well, does it evolve it by stages? Well, the first stage is an eyelash. The second stage is an eyelid. The third stage is a pupil. How does it do that? Because when you think about it, if it doesn't do it so it works together, like the mousetrap, everything works together, then it's useless for the animal concerned. In fact, it's worse than useless. Because if you have an eye which isn't protected by an eyelid, I would imagine infection could get into the system very quickly indeed and kill the animal. So a half-formed eye or a half-formed a lot of organs is absolutely useless to the animal. In fact, it's a way of killing it, not preserving it, not giving it a new innovative edge on all the other animal forms around it. It would destroy it. Come back to this idea, irreducible complexity. How does evolution, how does it create, dumb chance create a situation where all that complexity which you regard as part of your system works? How does it do it? Dumb chance. And you come back to, I think, an inescapable belief. You have been designed. And not only have you been designed, you've been designed by somebody who is so far above your intelligence. Not only have you been designed, but you can reproduce yourself. How does that happen? DNA, of course. And we understand that nowadays the complexities of reproduction are incredible. But we come back to the situation. Irreducible complexity. You can't have something formed stage by stage if it does nothing before it's finally formed. It has got to be there in its final form to be worthwhile. Otherwise, it's absolutely useless. In fact, worse than useless as far as animals are concerned. You've heard enough of me. What I want to do now for the last few minutes is have a look at a DVD. Well, actually, it's going to come on stream online. And I just want to look at a few sections of this. We'll take about 20 minutes to do that, see how we go with this, and have a look at a few. I mean, my qualification is BA Diped. That's all I am, BA Diped. But on the other hand, people sometimes prick up their ears when they hear somebody who's got a PhD, because of course that means they're a doctorate of something or other. So I've got a few here who are of a similar belief as I am in relation to creation and evolution, and yet are giving you different viewpoints. So we're going to look at natural selection, genetics, and the origin of life. Thanks, Christian.
Legend says that as a child, the great warrior Achilles was dipped in the river Styx by his mother to make him invincible. However, she failed to immerse the ankle by which she held him. Despite his seeming invulnerability, the mighty warrior Achilles had a weakness, a fatal flaw that would bring about his ultimate demise. In ancient times, philosophers and scientists struggled to understand their world. Today, that quest continues through observation and experiment. But from the beginning, our observations have always been interpreted through a lens, an already established belief about